Welcome to our exploration of scientific responsibility and biosecurity. In today's world, scientific advancements are accelerating at an unprecedented pace, bringing both incredible opportunities and new challenges. One of the most pressing concerns is how to ensure that scientific research, especially in biology and biotechnology, is conducted safely and responsibly. Biosecurity refers to the measures and protocols designed to prevent the misuse of biological research, whether intentional or accidental. As we dive into this topic, we'll uncover why biosecurity is essential and how scientists play a critical role in safeguarding society. Scientific responsibility goes beyond conducting experiments and publishing results. It encompasses the ethical obligations scientists have to society, the environment, and future generations. Responsible scientists must consider the potential impacts of their work, both positive and negative. This means thinking ahead about how their discoveries might be used or misused and taking steps to minimize risks. By embracing responsibility, researchers help ensure that science remains a force for good, fostering trust and progress. Biosecurity is a set of practices and policies aimed at protecting people, animals, and the environment from harmful biological agents. These agents can include viruses, bacteria, or genetically modified organisms. Biosecurity measures are designed to prevent accidental releases, theft, or misuse of dangerous biological materials. In research labs, strict protocols are followed to ensure that experiments are conducted safely and securely. This protects not only the scientists but also the broader community. Many scientific discoveries have the potential for both beneficial and harmful uses, a concept known as the dual-use dilemma. For example, research on viruses can lead to new vaccines, but could also be misused to create biological weapons. Scientists must recognize these risks and work with policymakers to develop guidelines that maximize benefits while minimizing dangers. Open communication and transparency are key to navigating this complex issue. Throughout history, there have been incidents where lapses in biosecurity led to serious consequences. For instance, accidental releases of pathogens from laboratories have caused outbreaks and public concern. These events highlight the importance of strict safety protocols and ongoing vigilance. By learning from past mistakes, the scientific community can strengthen biosecurity measures and prevent future incidents. Biosecurity is a global concern, and international standards help ensure consistency and safety across borders. Organizations like the World Health Organization and the Biological Weapons Convention set guidelines for handling dangerous biological materials. These standards promote collaboration and information sharing, making it easier to respond to emerging threats. Scientists must stay informed about these regulations and incorporate them into their daily work. Inside research laboratories, safety protocols are the first line of defense against biosecurity risks. These include wearing protective gear, following strict procedures for handling samples, and maintaining secure storage for hazardous materials. Regular training and drills ensure that everyone knows what to do in case of an emergency. By prioritizing safety, labs protect their staff and the wider community. Oversight committees play a crucial role in maintaining biosecurity. These groups review research proposals, assess risks, and ensure compliance with regulations. By providing independent oversight, they help prevent dangerous experiments and promote a culture of responsibility. Scientists work closely with these committees to address concerns and improve safety practices. Comprehensive training is essential for all scientists working with biological materials. Training programs cover topics like safe handling, emergency response, and ethical decision-making. Ongoing education ensures that researchers stay up to date with the latest biosecurity practices. This continuous learning culture helps prevent accidents and reinforces the importance of responsibility. Ethics are at the heart of scientific responsibility. Scientists must weigh the potential benefits of their research against possible risks. This involves considering not only immediate outcomes but also long-term impacts on society and the environment. Ethical decision-making requires open discussion, transparency, and a willingness to seek guidance when facing difficult choices. Biotechnology is a rapidly growing field with enormous potential to improve health, agriculture, and the environment. However, it also introduces new biosecurity challenges. Genetic engineering, for example, can create organisms with unpredictable effects. Scientists must implement robust safety measures and carefully assess risk before conducting experiments. Responsible innovation is key to harnessing biotechnology's benefits while minimizing danger. Preventing biological threats requires a multi-layered approach. This includes physical security, digital safeguards, and strong policies. Scientists must be vigilant for signs of misuse or suspicious activity. Collaboration with law enforcement and public health agencies enhances the ability to detect and respond to threats quickly. Prevention is always better than cure when it comes to biosecurity. Open reporting and transparency are vital for effective biosecurity. Scientists should feel empowered to report safety concerns or breaches without fear of retaliation. Transparent communication helps build trust within the scientific community and with the public. When issues are addressed openly, it's easier to find solutions and prevent future problems. Engaging the public in discussions about biosecurity is essential. Public understanding and support can help shape responsible policies and practices. Scientists should communicate clearly about the benefits and risks of their work, addressing concerns and answering questions. By involving the public, the scientific community can foster a culture of shared responsibility. Technology plays a dual role in biosecurity. On one hand, advanced tools like artificial intelligence and data analytics can help detect threats and monitor compliance. On the other hand, technology can also be misused, creating new risks. Scientists must stay informed about technological developments and adapt their practices to address emerging challenges. As research becomes increasingly digital, biosecurity must also address cyber threats. Hackers could target sensitive data or disrupt laboratory operations. Protecting digital infrastructure is just as important as physical security. Scientists and institutions must implement strong cybersecurity measures and stay alert to evolving threats in the digital landscape. SARS outbreak in the early 2000s highlighted the importance of biosecurity. The virus spread rapidly, causing global concern. Investigations revealed that lapses in laboratory safety contributed to the crisis. This case underscores the need for strict protocols, rapid response, and international cooperation to contain biological threats. One Health approach recognizes that human, animal, and environmental health are interconnected. Biosecurity measures must consider all three areas to be effective. Collaboration between medical, veterinary, and environmental scientists helps identify risks early and develop comprehensive solutions. This holistic perspective is essential for preventing and managing biological threats. Strong regulatory frameworks are the backbone of biosecurity. Laws and guidelines set clear expectations for safe research practices. Regulatory agencies conduct inspections, enforce compliance, and update standards as new risks emerge. Scientists must stay informed about relevant regulations and integrate them into their daily routines. Risk assessment is a critical part of scientific responsibility. Before starting any experiment, scientists must evaluate potential hazards and develop strategies to mitigate them. This process involves identifying risks, estimating their likelihood, and planning responses. Thorough risk assessment helps prevent accidents and ensures that research is conducted safely. Personal protective equipment, or PPE, is essential for laboratory safety. Items like gloves, masks, and lab coats protect scientists from exposure to hazardous materials. Proper use and maintenance of PPE are crucial for effective biosecurity. Training ensures that everyone knows when and how to use protective gear. Disposing of biological materials safely is a key aspect of biosecurity. Labs must follow strict protocols for waste management, including sterilization and secure containment. Improper disposal can lead to environmental contamination or accidental exposure. By following best practices, scientists protect both people and the planet. Every laboratory must have a clear emergency response plan. This includes procedures for containing spills, evacuating personnel, and notifying authorities. Regular drills help ensure that everyone knows their role in a crisis. Effective planning can minimize damage and save lives in the event of an accident. Biosecurity isn't limited to laboratories. Field research, such as studying wildlife or collecting environmental samples, also carries risks. Scientists must follow protocols to prevent the spread of pathogens and protect local ecosystems. This includes decontaminating equipment and monitoring for signs of disease. Effective biosecurity requires collaboration across multiple disciplines. Scientists, policymakers, public health officials, and security experts must work together to identify risks and develop solutions. Interdisciplinary teamwork leads to more comprehensive and effective biosecurity strategies. Prompt reporting of biosecurity incidents is crucial for minimizing harm. Whether it's a minor spill or a major breach, quick action allows for effective containment and investigation. Institutions should foster a culture where reporting is encouraged and supported, not punished. Biosecurity is an ongoing process that requires continuous improvement. Regular reviews, audits, and updates to protocols help address new risks and incorporate lessons learned. Scientists must remain proactive, always seeking ways to enhance safety and responsibility. Biosecurity is a cornerstone of global health security. Preventing the spread of infectious diseases protects not only individual countries but the entire world. International cooperation and information sharing are essential for early detection and rapid response to emerging threats. As science advances, new biosecurity challenges will continue to emerge. Synthetic biology, gene editing, and other cutting-edge technologies offer great promise but also raise new questions about safety and responsibility. Scientists must stay ahead of these trends, adapting their practices to address evolving risks. Conclusion: scientific responsibility and biosecurity are deeply intertwined. Protecting society from biological risks requires vigilance, ethical decision-making, and a commitment to continuous improvement. By working together, scientists, policymakers, and the public can ensure that scientific progress benefits everyone while minimizing potential dangers. The future of science depends on our shared responsibility to keep research safe and secure.